All right, so this video is about graphing linear inequalities. Let's take a look at the inequality that we're given, and we need a boundary line. We're looking for all the ordered pairs that make this true, where the y will be greater than or equal to if you took -3/4 times the x and then subtracted 3. We want all the ordered pairs that make that true. So we need the boundary line. The boundary line would be the equation y equals -3/4 x. So looking for all the ordered pairs that make both sides equal. So it's just like solving an equation there. Now to graph a line, notice it's already in slope-intercept form. Y equals mx plus b. So -3/4 x, that's your slope. And the -3 is your y-intercept. So let's go over here and we're going to go to the y-intercept of -3, put a point. I want to try and move it over a little bit. Oh, I don't want to move it that much. I guess it's good enough. -3. Now I need to have a -3/4 slope. So I can go down 3, 1, 2, 3, right 4, 1, 2, 3, 4, boom. Or I could have went up 3 and left 4. So I have a line, and I know it's a solid line. So if I wanted it to be a dash line, I would change it. But do I want it to be a dash line? And the giveaway is the inequality sign is greater than or equal to. So it can be equal. So the line, all those ordered pairs would make both sides equal. And it's allowed to be equal. So I need it back to needed to go back to a solid line. And then the last thing you do is you need to check to see which ordered pairs would work. All the ones on the line work, but all the lines above it, do they work? Do all the lines below it work? And the best point to choose is 0, 0, the origin. So I'm going to take the original problem and put a 0 in for y. I'm going to put the original sign in there. And I have -3/4 times x, which is 0, because the origin x is 0, y is 0, and then -3. I'm going to simplify that. We'll have 0 on this side. I have it greater than or equal to as the sign. -3/4 times 0 is 0, and 0 minus 3 is a -3. So I ask myself this question: is that answer a true answer? And the answer is yes. 0 is greater than a -3. So 0, 0 is an ordered pair that would be a solution. And in order to shade that way, I want to change my, got to go back to my tool here. I want to change the menu so I can pick shade. And I know 0, 0 works, so I tap there. And those are the ordered pairs that should make that inequality. Remember the original inequality, this one right here, makes it true. If you pick any ordered pair up here, like 4, 4, and you put in a 4 here, and you put a 4 in here, and you do the math, the left side should be greater than the right side. All the ordered pairs on the line are the ordered pairs that make both sides equal. That's why we started with the equation. So let's do a check. Let's hit that check mark here. See if we got it. Boom. I'll pause, erase, we'll do another one. All right, welcome back to the next example. We're supposed to graph this inequality. So we need the boundary line. The boundary line is the equation for the line that the ordered pairs would make both sides equal. So y equals 4x. To graph that equation, think about y equals mx plus b, slope-intercept form. The slope is your 4 and your y-intercept is 0. Add 0. So we know this is going to go through the origin. I know that the origin is a point on that line. Then I have a slope of 4. So I can rise 4, run 1, or go down 4, left 1. So let's go up 4, right 1, grasp my line. Now, do I want a solid line? It says less than or equal to. All those ordered pairs make both sides equal, and it says it can be. Now we're looking for the ordered pairs that make the left side less than the right side. And we can't test 0, 0 because 0, 0, the origin, is already on the line and it will work. So let's pick another ordered pair. Let's pick a real easy one. Let's pick 1, 1. So 1, 1, if I put a 1 in for the y, and I put the symbol less than or equal to it, and then I put a 1 in for the x, 4 times 1 is 4. Is 1 less than 4? The answer is yes, so I know that has to work. So I go over here, I tap the menu button, I want to shade, and I know that's going to work, so shade to that side. Bingo. Now let's do one more example together. Here's our inequality. If we had an inequality and the y wasn't by itself, we'd have to get the y by itself. Then we take that inequality and change it to an equation by just taking out the inequality symbol and replacing it with an equal sign. This is our boundary line. The y-intercept is a 2. So y-intercept is a 2. And it's a negative 4/3 slope, so I need to go down 4, 1, 2, 3, 4, right 3, 1, 2, 3. Or I could have went up 4 and left 3. And I notice that it's just a greater than sign, so it doesn't include the line. The line makes those ordered pairs make both sides equal. I don't want that. So I will change to a dotted line, and I can test 0, 0. So keep in mind, I want to use the original inequality. So I put a 0 in here for y. I have a greater than sign. Now you should be able to do this in your head, but let's write it out so you can see what I'm doing. Negative 4/3 times 0 is 0. 0 plus 2 is 2. Is 0 greater than 2? The answer is it is not. So 0, 0 does not work. Do not shade it to that side. So I'm going to change to shade. I'm going to shade away from the 0, 0. I'm going to shade up here. Good luck. Just watch out for negatives.